Hi everyone, David Maley here on Tech Know-How, and today I'm going to show you some really cool stuff. Today we're going to do data cleansing, and I know this is one of the more mundane pieces of data science. You want to go into visualizations and cool processes and stuff, but if you don't get the data cleansing done right in the first place, you'll never get there or never get the right insights. So this is very important. This is one out of the top 5 skills that employers are looking for in data scientists, data analysts, and anyone in the data science realm. So let's get started here. Today I have real data for you. So this is not like something someone found on a data set that has absolutely nothing to do with real life jobs. This is actual real data from a North Carolina, South Carolina based national oil change company. And it's actually a national oil change company, and these are numbers from their North Carolina, South Carolina stores, and they had a offer or a coupon that they set out to a certain subset of customers, and they wanted to test and see, who's going to take this coupon at $5 off, who's going to take it at $6, $7, $8, $9, on up to $10 off. Which coupons work best? Obviously, you think, oh, the $10 ones work the best. No, they don't, and you'll see here in a minute. So let me show you through this. What we're going to do today is I'm going to show you how to clean dirty data. So this data that came in from this campaign is got some issues to it. So we're going to do things like assigning better column names, okay? There's some columns that were missing their names. I'm going to show you how to do that. So that way when you have data that's missing column names, you can add it in, and you can add it to the column that you want specifically, not having to rename every single column or list every column just to do 1 or 2 columns. Then after that, what we're going to do is we're going to convert the date fields to the correct data type, because obviously they're the wrong data type. If you have them in Excel and they come out like 42519 or something like that, you need to have it as the correct data type. I'm going to show you how to do that. Then I'm going to show you how to look at the data and see, is it in the correct format, and is there any outliers that are messed up? We will address that. Then what we're going to do is we're going to remove missing values or nulls. We're going to deal with that. We're going to deal with that twice, actually, because in one case we actually input them with a change that we have to do. So we'll get rid of all the nulls in the correct way, and I'll show you how to do all that and test for that. Then we're going to remove garbage data. Garbage data happens all the time, especially when you have hand input data. And I'm going to show you how to remove that, so that, like if somebody puts in a zip code in their last name field, or somebody puts in the seller's name in a dollar sign or a numeric field or something like that, I'll show you how to change all that to fix the data types to get it back the way it's supposed to be. Then in the end, we'll do some quick insights based on this data to show you that we now have it correct and it's all good. And then we can use it further later on for further analysis. That's not the purpose of this. The purpose of this is to get your data cleansed and correct so that you can do stuff with it. So let's start off at the beginning here. First, what we're going to do is we're going to use these libraries, Tidyverse, OpenXLSX. Obviously, we have to use that to open up a text file. It comes in this case, it's a flat file, Plotly, and Zoo. So you add in these right here. If you don't have them, do install.packages and quotation marks and the name of the thing. So you would do that like this, install.packages, just right here. You click on this. This is RStudio, by the way, in case you don't know that. And then you would put, like, for instance, if I didn't have Zoo, I would put in there and I'd run this, and then I'd run the library. Okay, let me put that at the beginning of this. Let's go down here and put the comment on it, so that because I don't need that there. All right, so next what we're going to do is we're going to load the data. Now here's the data right here. So as it says right here above it, this is a subset of North Carolina, South Carolina customers from a national oil change company that were sent 2 batches of coupons in 2016. They were sent one in, I think it was June, and then one in December of that year. So that's what this is. So we're bringing in this on my local drive here of the North Carolina oil change driver data. So once we've done that, what will happen is that'll go into test 1. That's right here. And originally, let's just clean this out, right? So let's remove all that in our global environment, and let's bring it in fresh. So you can see there's 244 rows, right, before we clean anything. Let's run that. All right, there it is, 244. Okay, now don't worry about little warning messages down there. Now, next we got is assign. Well, first let's take a look at the data. Right, so we got test 1. Let's look at it right here. So look at this. We got dirty data and coupon discount amount. These are supposed to be the amounts, $5 through $10. We got somebody put Monday, and then somewhere down below here, where is it? I remember seeing this down towards the bottom here. There's somebody's last. There we go. Somebody's name, the salesperson's name or customer name or something's there. We've got missing data I know of in here. See those NAs in the customer ID field. And we also know that because we have these text letters inside of this last column, which is supposed to be numeric, it's not going to be numeric. And then there's other facts or problems in here too, like look at X6 and X7. What are those? Those are bad column names. This is actually the date in Excel format, so we got to fix that. And then X7 is going to be the coupon number. So let's go and look at this. And let's first start off with loaded the data. We have it. You just saw it, right? Now, we know that X6 and X7 were bad columns, right? Let's go back to this, take a look at that real quick. See that right there? Bad column names. The rest of them are good. You can go and list all of the column names and redo them. That's a pain in the butt. When you're only doing 2 or 3 of them or something like that, and you want to do a couple of them or one, what you got to do best is this right here. So this is how you change the column names. See that? Names, the names function of the DataFrame, which is test 1, right? And then we're using position 6 and position 7. So position 6 was the column for X6, and then position 7 was X7. And we're changing it to date and coupon. Okay? So once we do that, let's do that. I can run them one at a time or run them both. It doesn't matter. Now if we look at the data, right? Look at that. Now we got date and coupon there. Okay? That's what we want to do there. That's a very simple one to do. Now we're going to convert the date field because the date field, remember, is the wrong date field. So if you go back here to date, look at that, 42542, and then see this one down here, 28214. We know that's an outlier. That's going to be from somewhere in 1970 or even before. So that one's wrong right there, but we'll deal with that in a minute. So first, let's do this. Convert the date field to the correct data type. So if we do str will give us what? What do you think that's going to give us? It gives you this, which is the listing of each type of data. So is it numeric or is it character? Well, that last field, remember the last column, I'm sorry, last column, not last field, needs to be numeric, right? Oh, it's character. You know why? And I can say with those quotation marks and the CHR, because it's got Monday and that person's name in there. That doesn't need to be in there, so we got to fix that, right? But we're right now looking at the date. So we're going to start with date too. So date is numeric. See that right there? That's the date, numeric, and then it's got the numbers next to it. Well, there's numeric numbers. If we just convert them over with zoo, it'll do that. If you don't use zoo and try and convert them over immediately, what happens is you'll get a wrong date. You'll get something like 2086, which is many years in the future, and we don't want that. Okay, we want correct dates. So this is from Excel date type, or where it's numeric in Excel for a date. So what we have to do is convert it, and in converting that for Excel, you have to use this. So you need to use the origin date, and the origin date for Excel is 1899 12-30. Don't ask me why, it's just the way it's created. So if you utilize that, okay, that's this function here, as.date, the original data frame, the date column, see $date, or an origin equals 1899-12-30. That'll come up correct. So let's take that. No, let's do this correctly. And let's do that. And what we do is Control Enter. That takes care of that. Now let's take a look at that. So now let's go back here. Let's look at the date and look at that. Now we got them correct. Now remember that one that was weird? Yep, there it is, 1977. So that one's bad. We'll deal with that in a minute. Okay, but now we have them looking correctly, right? So now if we plot this data, this is where we're going to see that other one if we didn't see it already. If you use this ggplot test1 aesthetics of x equals test1 date and y equals test1 quantity that sold, you could pick anything you want there. It doesn't matter. I just want to plot. I could pick the quantity amount too, plus geom point. If you run this, right, look what happens. You've got all your data right here, except for this one. And that's that one we saw earlier that's 1977 or something. So we got to get rid of that. So how do we remove that bad date? And again, if you want to see it again, it's right here. And it is right there, 1977, because it was just a bad data. So let's go back here. We're going to remove that row. Okay, that's what we're going to do in this case. So what we're going to do is we're going to use this function right here, which is the subset function. Okay, and it's subset of test1 comma date greater than or equal to, and in this case this would be where are your date ranges? So for me, I know that it's 2016. All of these campaigns were in. The two campaigns, one was in June and one was in December. So we know that if we put 01/01/2016, it's going to remove that 1977 date in there. So let's run that. And then when we do that, that one's gone, and you see it drop to 243 from 244, right? We didn't lose any variables, but we dropped one row. We just dropped that row out. So now if we go and either plot this, or if we go and look at the test one data, we'll see it's gone. So see where that one was on the left here? Let's run this. And there it is, it's gone. Now you got July through January of that year. And you know by seeing this, it makes sense. We had a campaign here in June, and we had a campaign here in December. Obviously the campaign in December had more dates or points. That's fine, it doesn't matter. It could have been a bigger campaign here than there. That doesn't matter, or more responses. But the data looks good at this point. So we're done with this part of converting date fields, right? Next, what we need to do is we need to remove the missing values and nulls, right? So I showed you earlier there was some nulls in the customer ID field. If you didn't see it, let's look back there. There's one sitting right there, customer ID. There's an NA, and we know there's more than one. There's another one. Okay, so we got some missing customer numbers in there. So what we're going to do is we're going to first identify the NAs. This is called the completed cases function. So by using this right here, just complete dot cases and your data frame, just run that. And what it does, it just shows right here like a print to the screen. It shows you the false. The falses are what? They are the nulls, right? So we know we have them. There's also other methods that give the exact number and column. So let's do a summary instead, right? So this one gives you more. The first one just identifies we do have, once you see those falses, you know that you have some NAs. But where are they? What column are they in? Kind of hard to tell from that. So let's do this. The summary gives me a summary of all of the columns, right? Customer ID, store number, transaction number. But look down below where if there's any NAs, it says it right down below. NAs, if you don't know, is missing information. It's not there. It's, we can't work with NAs in many fields, okay? Can mess things up. So we've got 4 in customer ID and none in any other column, okay? But we have 4 in customer ID. So now that we have that, what we want to do is we want to identify those rows, right? So what I'm going to do is before I remove them or deal with them, I want to first record them so that in case I need them back for something, I have them. Because if I just go ahead and remove them, they're gone. Now I don't have that data anymore in case I need it. So what I'm going to do is I'm going to run this right here, which takes a subset of test 1, right, which is our data frame, where they are NA, so it says 4 rows, right, and for customer ID only, where it's NA, and I'm going to put that into this new data frame called test 1 NAs, or test 1 with NAs, whatever you want to call it there. Once I run that, look at that, 4 observations, there it is right there. I've now recorded those 4. Now, in this case, because they're blank, I don't have a card number for them. They're not a loyalty program customer. So what I want to do is I want to record them instead as a new customer. So when a new customer walks in, they pay cash. They don't have a loyalty card. What happens? They get recorded as a 0, right? So they're still there. We know who they are. We know they came in. We just don't know exactly who they are. But that's fine. There's still data. They still redeem those coupons. So what we want to do is we want to set them to 0. So that's what this is right here. So test 1 frame or data frame is NA test 1. So what this is doing right here is it's basically saying set any missing data or NAs to 0. That's basically what this does. It takes a 0 and inputs it into that. So let's do that. And now if I go back and I do this summary, remember we did the summary earlier to see where the NAs were? Now look at the customer ID field. There's no thing at the bottom that says NAs. None of them have NAs. So we're good. The NAs are all gone. So we just took care of it. We just tested that. We removed them. And we also saved them if we need them at a later time. Sometimes if you have a lot of NAs, or if they're important NAs, like they can cause skewing and stuff, you might need to deal with them differently. All right. So next we're going to do is we did that. We're going to do removing the garbage data. So now remember we had in the last column, let's take a look at this. We had somebody's name and Monday in there, right? All right. So what we want to do is first, let's do this, right? And what's the problem here? The problem is, remember we first determined that the last column was character column. Why? Because there was Monday in there, and there was, what was the other thing? Somebody's name in there, right? So that's why it's character. Well, that last column, to work with it, we need it in numeric format. So I need to change this from character to numeric. Now, or to integer in this case. So converting the column from character to integer, what we're going to do is we're going to use this. All right, so this right here is what we can do is we take that field, test1, DataFrame coupon.discount.amount, and we just set it as integer, that whole thing, and set it back into itself. That's what we do right here. So if we do that, look what it says below. Oh, NA is introduced by coercion. So what that means is those fields, that Monday and that person's name, I don't remember what the person's name was, those become NAs because they're not numeric. It doesn't know what to do with them. That's fine. So we now know we have two NAs in there. We could also run a summary of this if we wanted to right here, right? And look, or we actually have one NA, I'm sorry, one NA. All right, so we got one NA in that last one. So now that the problem is we got that NA, so how do we remove it, right? So we've introduced the two NAs. What we want to do is we want to identify the NAs, right? Same things we did before and set them aside. So this is going to be test version 2 of the NAs. We're doing the same thing we did before, right? And what that does, it puts that NA into this right here of 9 variables, one observation, and it's saved for later if we need that. Then we remove the 2 rows, or in this case the 1 row. So let's make that 1, not 2. That's fine, whatever. With NAs in the coupon discount amount column. So what we do is we run this, and what this does, it says test 1, but we want, instead of is NA, we put that little exclamation mark in there. It says not is NA, and we're putting that in test 1. So what we're doing is we're saying I only want the non-NAs in test 1. All right. So what we're doing is we're removing that 1 row. We're not, putting a value to it or anything. We're just removing it. So let's do this. Now look, it went to 242, right? So we removed a row. So now if we hit this, the summary again, we see there's no NAs at the bottom of any of these, right? None. Whereas before, there was right there. Now it's gone. So the NAs are all gone. So far what we've done is we've done what? We've assigned better column names, remember, the X6 and X7. We've converted the fields to the correct data type, the date range especially, which was messed up coming from Excel, and that happens very often. It shows you exactly how to deal with it. For flat files, and you're inputting flat files from Excel. Removing missing values and nulls, that happens quite often. Also removing and collecting garbage data. So we've all got it recorded. So for instance, if they say, well, how did you get garbage data? Why did you remove those rows? Here it is. That's why. We had somebody's name in the field. We had NAs. We had missing customer IDs. So if they need that for further identification, we have that. We don't just remove rows. We don't just change data, we also record it so they can see the before and after if they need it. Then when we're done, because now we've got pretty data, right? So if we were to go back and look at our data, now it's nice. Now we have all numbers, and this is numeric, so we can work with it correctly. We have the correct dates in there. We have all of the customer IDs filled in. That's good. So let's go back here. Now, let's do some quick insights on this, right? So remember we were talking about earlier, this was a breakout of coupons for $5, $6, $7, $8, $9, and $10, right? At different times of the year, and to see which one worked best, right? And you'd say, oh, well, obviously everyone's going to take the $10. Really? Let's take a look here and see. So if I take a histogram, right, which is the hist function on test 1 coupon, right, discount amount, if I take that and just run that, let's see what that does. Okay, so let's pull this up a little bit bigger so you can see it better. What that one right there is showing you is that at 5, 6, 7, 8, 9, and 10, here's what actually happened. So actually the majority of people were at 7 or at 5 and 6. The majority was here, actually not here, and the least was at 9 and 10, especially at 10. That's interesting. That is counterproductive to what you think. But it could be, it depends. How did they reach these people? What time did they reach them? What kind of deadline did they have to use these coupons? How close were they to that location? How long has it been since their last oil change? There's a lot of factors that play in here, but it's still some really interesting data. Now, if we take that same thing and instead we use the stores, right? Store number. So we got test one, $ store number, and we use breaks of 0 and 70. The 70 can be whatever you want depending on your data. But let's do that. Watch what happens. This shows you by store number, right? So we got it shows you how many people redeem these coupons. So obviously store 0, which is in our, if you look at our test 1 data, store numbers, well, they're kind of rounded off wrong. We could change that here, but there's a low store number here around 1 or 0 that had an awful lot of representation. That one store did a lot versus these others did some, but see, there's some that had very little participation, and that one had an awful lot, more so than the rest. Maybe they were all in close proximity to this store. Maybe these stores are all close to each other, but they're closer to this one. Maybe this one's on a major highway. I don't know that, but that's what's interesting here. So I used the cutoff of 70 because there was no data points beyond that. If there was, I could have used a cutoff of 100 or 200 or whatever. Okay, so that's how that works. So now you've seen we cleansed the data, right? I showed you the libraries we used. We loaded the data. We assigned better columns. We converted the date field to correct data types. We removed missing values and nulls. We corrected the garbage data, and then we even got some quick insights on this data. So that's how you do data cleansing. Now there's some different variants to this and stuff, but this shows you exactly when you have data and it's dirty, how to go and take it and make it pretty and nice with a, and once you've created a process like this, you can reuse that on all the other data that you have, with maybe some little tweaking here and there, depending on, are you going to be replacing values or are you going to be removing values? And any time that you replace or remove values, as I showed you here, you always want to document back up what you're removing, because that way you have it in case someone says, hey, I didn't want that removed, or hey, we want that. We had a meeting where we determined, of course you weren't in that meeting, that's what usually happens, but they determined that they wanted that data dealt with differently. And that way you have it, and you say, oh, no problem, I can bring that back in. It's simple. Very easy to go back and bring data back in rather than having to go back through a process all over again. In this case, it's a short process, but it doesn't matter. It's still good to always document yourself and always to, whenever you're going to remove or get rid of data or change data, that you're documenting what it was before. And these are the 4 that we had missing data from, and these are the ones that had the wrong data type and so on. All right, thanks again for watching. Please take a moment to subscribe, like, and share. And also, feel free to leave me a comment. I'd love to hear from you. Give me some ideas on what you'd like to see next, or what you like and what you don't like. All right, thanks again, and have a great day.